Hello, everyone, and hello, YouTube as well. I have now figured out how to time it right at the same time. Hope everyone is doing okay. Did anybody get any observing done this weekend? Let us know.
I was out last night on the driveway. I missed a chance. I was going to look at more of the Auriga features we're talking about today. I got to see a couple of them, so I'll mention that. And I got to see the comet.
Oh, you gotta see the comet.
Boy, was it ever faint last night. But
I haven't even tried. I didn't, because I haven't had equipment out in a while. But yeah, I was out in just about an hour southeast of Winnipeg this weekend in the country. So I saw a lot of things with my naked eye that I usually have to use binoculars for. I just Your M42 just popped out at me, the Pleiades. It was almost too many stars for me to be able to identify. So that was really exciting. But didn't see anything special. I was just seeing everything I could. Hello, everyone. Yeah, feel free to drop your name in the chat and where you're coming from. And if you have any good Valentine's Day astronomy puns, feel free to share those as well. And we'll give like 30 more seconds before we get started. Oh, somebody else saw the comet. Awesome. Gastown, Vancouver, Ottawa, Ancaster. We're coming in fast now. Okay. Well, people are still filing in, but I think we can get started. Have not seen the comet yet, and I think just to mention that there's there's I don't think there's any more time to see the comet. Can you still see it, Chris?
oh yeah, it's actually going to fly past Aldebaran, I think tonight.
Okay.
So it's up there in the evening sky. It's a very conveniently positioned in the evening sky, but it's fading now in brightness. So the sooner the better for folks.
That's
And the
a
moon is
so
gone. So now the moon's got out of the way. It's a little easier for that.
so we're kind of just in the final like best time to view it. How long can we still view it?
Well, it's transcert. I don't know. I was having a bit of a chat with Carrie Ann Lucky Hepburn today on Instagram, whether she could see it, whether one could see it with binoculars. And I suggested that might be tough from the suburbs, but I'm sure there are a lot of rascals that have great dark skies that can see it from where they are still with binoculars, but definitely it's telescope time for most of us.
Awesome. Well, that's great news. You can still see it. And with that, kind of already started, but let's get into it.
Yep.
Welcome to, did we say our 65th episode of
55th.
Insider's Guide? Oh,
Yes.
and today we're doing another constellation deep dive. I have no announcements from RAS National side of things, so I'm just gonna let Chris take it away.
Thank you very much. So yeah, I don't know if you've been up outside and looked up with a clear night in the past little while, but the bright star Capella is shining right overhead around this time of the year for Canadians. And that's the showpiece or the bright beacon that dominates the constellation of Auriga. So I actually like from time to time, I like to write up a detailed tour of the different constellations. And we've already done Orion on Insider's Guide. I don't think we've done Taurus, but I thought I'd flip over and I would do Auriga because it doesn't maybe get as much love and attention as it could. So we can promote that. So let me share my screen and we'll dive in and talk a little bit about that. So here we go. Screen, and go. Boom. Cool. So there's the evening. Oh, let's see if I can get this to work. There we go. What's going on with my stellarium is misbehaving.
There we go.
They're coming through now?
Yep,
Okay,
we can see it
good.
now.
All right. So let's bring it up into this evening sky. Here we go. So as I mentioned, the green Z on my display here is the zenith straight overhead. And this is the scene for about 8:30 p.m. I'll just round it up to 8:30 p.m. Do this. Oh, my computer is definitely not happy about something. Let's see if it'll settle down. Here we go. Are you seeing that okay?
Yep.
All right, good. Every once in a while it does this. So there's the green Z up above and the bright star Capella. So the February evenings are great for seeing these winter constellations. This is the mid-evening sky around 8:30 p.m. in Canada. And Auriga is one of the original ancient constellations that were in Claudius Ptolemy's Almagest star atlas. He published that one around 150 CE, or after the year zero, since the year zero. And now it sits north of the celestial equator. So the greenish line here is the celestial equator. And it's about 40 degrees or so above the celestial equator. So that means that it's not visible widely around the world. It's visible from the northern hemisphere and from the tropics. But by the time you get to, the below the equator, it starts to sink lower in the sky. So I've got here that it's visible from equatorial latitudes, and for much of Canada, it's actually circumpolar. So I think everything but southern Ontario, the constellation is circumpolar, which means it's up 24 hours a day. Now the constellation shape is this nice ring shape, or kind of a pentagon shape, or I don't know, sometimes I look at this and I think it looks like a stubby coffin shape, but basically we're going to consider it kind of a ring shape. And it measures about 17 degrees east and west, or north and south by about 12 degrees east and west. Now, Capella is actually at the northern end of the constellation. And one of the things about when you're working with Stellarium or an astronomy app is if you're trying to look at an object that's in the northern sky, you can see if I'm moving the cursor left and right here, the constellation tilts because it's trying to kind of deal with Polaris and where Polaris is. So one of my advices, if you're dealing with that, is head on down here to the bottom and click the equatorial mount. So now celestial north is up, and I can move it left and right, up and down, and it's not rotating around. That makes it easier when I'm trying to tour the stars, because if I want to say that a star is to the lower right of another star, that's only true when the constellation is upright. But at different hours of the night and different times of the year, it's going to be circling the pole. So it could be upside down or on the side. So I'm just going to assume that we're viewing it with north up. So Capella being the star kind of closest to the north celestial pole, which is right there, Polaris. And then at the other end of the ring, the other bright star in the sky in Auriga is the star Elnath, which is actually part of Taurus. That's one of the northerly horn-tip stars of Taurus. But that's fine. We're gonna sort of use it to make our ring of the Charioteer. So it's bordered on the east by Gemini. I'll just put up the borders here so we can see them. Bordered on the east by Gemini and Lynx. Bordered on the west by Perseus. On the north by Camelopardalis. Not a very well-known constellation in its own right. And then on the southern border, it's got Taurus, the bull, as I mentioned. It does now. So the constellation has been depicted in a number of different ways. And if you start reading its history, you get down a bit of a rabbit hole. It gets a little bit complicated because there are times when the constellation was considered kind of a shepherd's crook. And that's the reason why the bright star Capella is nicknamed the goat star. And it's represented in most celestial maps or drawings of the constellation as a goat sitting on the charioteer's shoulder. So he's meant to be a charioteer. This could either represent the person's body, the charioteer, the driver's body, or it could represent the vehicle itself. There's sort of different ideas around that, around different cultures. And as I said, the star Capella, being the brightest star, you might think it would be dominating the person's head or face or something like that, but actually it represents, in most star maps, the goat. He's holding a goat on his shoulder as he's driving the chariot, which is weird. So it's kind of like somewhere along the way, the constellation got blended so that they had to sort of compromise the two stories and combine the goat idea with the chariot idea. But that's kind of the way it looks. If I bring up the artwork in Stellarium here, you'll see kind of what I'm talking about. So there's the picture of the goat. Now, there are three little stars that you can see with your naked eyes to the southwest of Capella, little narrow triangle formed of these three stars. And their nickname is the kids, as in baby goats. So you've got the big goat for Capella and then the baby goats for the kids. And again, that idea around the goat and the shepherd's crook, you know, may have been representing the sort of arc of stars and down into Taurus. That comes from, you know, Mesopotamia, the Sumerians, so the ancient time. Now, in the pre-Islamic astronomers, there's a gentleman, astronomer by the name of al-Sufi, Abd al-Rahman al-Sufi, from the pre-Islamic era, and he produced star charts and maps and a book, a famous document called the Book of Fixed Stars. And I'm just going to bring up the star lore here and show you some different depictions of Auriga this way. So if I scroll up in Stellarium, I can go into al-Sufi himself. This comes up. And there you can see what he's looking like from al-Sufi's perspective. So you've got the ring of stars does represent his torso, but his head is actually offset to the north a little bit. And if you noticed, I don't know if you got, yeah, I'll go back to the Western here in a minute. The constellation itself has a kind of an empty section to the west. So the bright stars of the constellation tend to be grouped in the western side of the territory. And there's kind of an empty spot to the west, to the eastern side. And that is actually representing kind of his flail or his prod or whatever, you know, instrument he's using to drive the chariot. I'll come back and show you in detail what some of those are in a little bit. Now, a while back in 1789, let me go back to the Western here. One of the other sort of curious aspects of this patch of the sky is that in 1789, a Hungarian astronomer by the name of Maximilian Hell, he actually combined some stars from Gemini and Lynx to produce a new constellation called the Herschel's telescope, or Telescopium Herscheli, in honor of William Herschel's discovery of Uranus. I'll just show you a picture of what that looks like. And as you can see here, here are the stars of Auriga. Here is that flail or whip in that part of the constellation. You've got Lynx to the northeast, and then you've got down here where Gemini is this telescope. And of course, a lot of constellations get, you know, become defunct after a while. We stop using them after a while. So this one's fallen into disuse, but I thought that was kind of a curious thing to think about when you're looking at this patch of the sky. Now, the stories that sort of the Greek mythology stories and such that go along with the constellation of Auriga, one of them was that he was the Greek hero Erichthonius of Athens. He was the son of the god Hephaestus and raised by the goddess Athena. And he invented the four-horse chariot. And then therefore, he created the chariot in the sort of the image of the sun's chariot, the Helios's chariot, and he used it to be in battle to become the king of Athens. That's one story. And then Zeus raised him into the sky to honor his heroic deeds and his ingenuity. In another story, he may have been Hermes' son, Myrtilus, or Theseus' son, Hippolytus. And there were both well-known charioteers in mythology. And then there's Bellerophon, who was the original rider of Pegasus. He was also linked to this constellation at some time. Now, the Chinese saw a chariot in these stars, completely unconnected as we would imagine. But one of the neat things about the Chinese view of the constellation, if I bring this Chinese sky up here, Chinese medieval, here we go. Oh, let's do the Chinese medieval, here we go. Is that you can see that here's the ring of Auriga with Capella now named the determinative star. And what you can notice if you're looking through here is that there are minor stars kind of within and beside the ring, the main ring of Auriga. And these have been grouped into little kind of peaks or V shapes or little L shapes. And what these are meant to represent are actually the hitching posts for the horses used to drive the chariot in their stories. So I thought that was kind of fun. Then in the, let's see, in Australia, that's the Burong. So the Burong people, they actually see these stars, particularly Capella and part of Perseus, as Pura, the red kangaroo. And then the Inuit, where's my Inuit? The Inuit link together Capella and the other bright star of Auriga here, down with Castor and Pollux to make the collarbones, or Couturjuk. I'm not sure the correct pronunciation of that. And one of the neat ones is the Lakota. So I don't know if you've noted or knew of the sort of big winter hexagon or winter triangle, winter football. Let me just bring this up. So the winter football is or winter hexagon is the ring of stars produced by Sirius and Rigel and Aldebaran and Capella and Castor and Pollux and Procyon, making this big loop in the wintertime sky. The Lakota people call this the sacred hoop, and Capella is part of the stars in the sacred hoop. So those are a few of just a sampling of some of the other sky culture that are used, that Auriga factors into. So when you're up looking at the constellation, look for these little stars in the interior and imagine those hitching posts. All right, so let's do a tour of the main stars, and I'll just point out some of the fun facts. So one of the great things about doing an in-depth tour of a constellation like this is to equip yourself with interesting fun facts about each of the stars, if they have them. And that allows you to share some more interesting, engaging content with, people that you might be showing the constellation to, or touring the constellation to, or in the sky. So as I said, Capella is interpreted as the goat star. The name Capella is Latin for little she-goat. It's actually the sixth brightest star in the entire night sky. It's a multi-star system. There are actually, I think it's up to, let's see, well, 15 stars kind of grouped in the bright star that we consider to be called Capella. Only one of them, I think there's only, two of the stars are gravitationally bound red dwarfs near Capella. The other stars in that collection would be line of sight doubles, or stars that are sharing the same coordinates in the sky, but are either closer or farther away than Capella is. So the brightest components of Capella are actually two G-class sun-type stars. They orbit each other every 104 days, and they're only separated by 0.74 astronomical units. So that's basically the orbit of Venus around the sun. So that's tight. Let's see. Now, one of the neat things is that if you're looking at Capella in a low magnification telescope, there's actually a group of 5th and 6th magnitude stars kind of in a line across to the north of it. And it almost looks like, Capella's the conductor and they're the audience, or he's the king of the court, and these are the members of the court sort of gathering around the main star. It's quite a neat view in a telescope. All right, so let's start wandering around the constellation. I'm going to wander around kind of clockwise here. So from here, we're going to hop down to the top or northerly of the three kid stars. So that's Almaz. Its name means the he-goat. It's an F-class star. It emits nearly 47,000 times as much energy as our sun does. It's also an eclipsing binary system. So if you remember back to our variable star sessions, it's a star that has a pair of stars with orbits that are nearly edge on to the Earth. And so this star dims by 0.9 of a magnitude for a 2-year interval every 27.1 years. It's one of the longest known periods of that class of objects. And it might be due to a large patch of dust, opaque dust that is orbiting that star that causes it to dip in brightness for such a long amount of time. Below Almaz, we have the two more kid stars. These are actually Eta and Zeta, or Aurigae. Now you will, in your app, your app may give them different names. They do have different names in different apps. The word HIDUS. So I think in Sky Safari, these might be called HODUS, HODUS 1 and HODUS 2, but in Stellarium, they're labeled HADUS and Saclateni. So the word HADUS actually means, it's a Latin word that means baby goats. So that's why it's got that name. So HADUS comes from a name that means the baby goat. The Saclateni also is sometimes called Sadatoni, and those come from Arabic expressions that mean the second arm of the charioteer or the rein holder, so holding the reins. Now, the Zeta star is another eclipsing binary star system. This one dims by 4 magnitudes every 2.66 years. That's quite a dramatic drop every now and again. All right, let's jump on down. So we're jumping down by about more than a palm's width south. This is now down to the star Hasela. Some apps call this star Al-Kab or Hasela. It also means the shoulder of the reins holder. It's a K3 class star, kind of an orange colored star, about 500 light years away. It's more luminous than it looks, so it should be brighter than it actually is. It should look brighter than it does, because it's actually being attenuated or dimmed by a lot of interstellar dust. So we see it as magnitude 2.65, but it should have been brighter if it weren't so obscured by that dust. This star is actually at the lower limit for turning into a supernova, exploding as a supernova in mass, and the upper limit in mass for white dwarfs. So it's kind of at that border between the planetary nebula end result and the supernova end result. So that's kind of a neat thing. And then we come down to Elnath. As I said, that's the northerly horn-tip star of Taurus, but this does have an alternate designation. So if you go into Stellarium's info, you can see here it's both known as Beta Tauri, but it's also known as Gamma Auriga. So it kind of does dual duty on the two constellations. And it's a bright star. Okay, so from Elnath, we're going to hop up to the northeast. We're going to jump all the way up to this star Theta, or Mahasim. Theta is Arabic expression derived from the wrist of the charioteer. And it's a hot, white, A-class star. It's about 173 light years away. It's got a very intense magnetic field that we've been able to measure. And that's herded elements like silicon and chromium into patches that appear and disappear as the star rotates every 3.61 days. So it affects the spectrum of the star on that sort of a time cycle. Heading up a little bit north from here, we run into this pair of stars, Nu and Tau Aurigae. They shine together just inside the ring here. They're both about 200 light years away from us. And these are part of the hitching posts that I mentioned here, the Chinese constellation hitching posts. Now from here, if you want, you can head inside. We'll just interrupt our tour around the rim for a second and just jog from Nu and Tau, go to the west, and you can pick up with your binoculars this triangle of stars, Alhiba, Alhiba 1, Alhiba 2, Alhiba 3. The word Alhiba refers to the word or Arabic phrase for the tent. And so I guess they imagined that this was kind of a tent shape. And those are actually the stars Mu, Lambda, and Sigma Aurigae. Lambda is the nearest one. That's this one here. It's about 40 light years away. It's similar to our sun. It's a G-class star, similar to our sun. Mu is a whitish star. I think it's about 40 light years away. And then Alhiba 3 is more than 500 light years away. So they all have sort of a similar brightness, but they're radically different distances away. All right, finishing our tour of the ring, let's head on up to the corner star here of Beta Aurigae. That's Menkalinane. McKellanen comes from a phrase that means the shoulder of the rains holder. At magnitude 1.9, it's an A2 class star, so whitish star. It resembles Sirius or Vega, but it's much farther away than Sirius would be. It's about 10 times farther away at 81 light years away. And, you know, that makes it dimmer in apparent brightness. Now, just above that, if you're checking out McKellanen, don't forget to check out Pi Aurigae. It's nice, very deep red M-class star, just to the north of Beta. That's a swollen red giant star. It's about 780 light years away from us. Now, pulling back a little bit, remember that image of the Al-Sufi image of the constellation where we've got the body of the chariot driver down here, and the head of him was way up here at this star, Delta Aurigae, or Prajapati. So Prajapati is a star that means the Lord of created beings in Hindu. And if you bring up the other neat thing is that the line drawn from Menkainen through Prajapati basically points to celestial north. So you can see that vertical line here up to Polaris, giving you that direction. Now let's talk about this empty side of the constellation. So if you zoom in with binoculars, you'll start picking up some medium bright stars, sort of in the magnitude 5 range of stars. And just zoom in here a little bit. And these stars are all named Dolonas. They're actually all named Psi. So Psi 1 through Psi 10 Aurigae. Don't know why you would take a whole bunch of stars, individual stars, and assign them all the same Greek letter. I hadn't been able to find why that is, but their Greek letter is Psi 1 through 10, and their kind of proper name, Dolonis. Dolonis means prod or pike, kind of implying the tool that the driver's using to encourage the animals to pull the chariot. By the way, Dolonis 10 or Psi 10 is actually in next door links, so it actually is beyond the edge of the border of the constellation. So yeah, they're not even arranged in any particular logical order or order of brightness. They just sort of got randomly assigned in some curious fashion. But anyway, that's the kind of empty patch or empty side of Aurigae. All right, I'm going to stop there for a second and see if anybody had any questions so far.
Feel free to ask any questions in the chat or the Q&A as well. YouTube, we are monitoring that chat. I would say the one thing that got me about Auriga is the fact that it does share that star with another constellation. Is that common with constellations, or?
No, I'm not sure many that do. I think this is the only one that comes to mind. Well, I guess Alpheratz, right? Because Alpheratz is the corner of Pegasus's square, and it's also the head of Andromeda.
Yeah, so I was gonna say that was another one I ran into recently, and I was very confused that I was trying to make a star chart and I couldn't figure out where one ended and one began. So that's cool. Interesting that, yeah, especially because there's so much, like, the constellation lines are to the one side, not the empty space. I don't see any comments in the chat or in YouTube.
Okay.
Everybody just, you're explaining it so well. Oh, there's a Q&A.
Bring up, so what I'm doing here now is I brought up a green ring that represents the field of view of binoculars, you know, about 6 degrees. Maybe that's a little larger than most binoculars, but it's roughly the field. And we're going to use this to check out a few nice binoculars doubles that you can enjoy in the constellations. So first one up.
Oh, sorry. We have one question pop up. Is Capella a binary or a double star, or is it just on its own?
It's a binary. Yeah.
Binary.
Yeah. So it's got as I mentioned, it's got a companion. That's the one with its 104 days, separated by the distance between the sun and Venus.
Pretty close.
But they're so close together, they're both G-class stars, so we see it. Capella, the combined light of those stars just makes Capella look like a brighter G-class star.
Okay, thank you.
Good question. Okay, so if you want to check out Auriga with your binoculars, I always like to point out some things that are great for anybody to just look up and look, gaze up and look, or maybe grab simple binoculars and enjoy a few sights to see. So what you can check out is a number of pairs of stars that will fit nicely in binoculars. So first up, we've got this wide pair of stars in the western side of the constellation between the Kids and Hasela. That's 1 and 2 Auriga. So these are both essentially K-class stars, K3 class stars, so kind of twins, but they're widely separated. You could probably pick them up. If you've got a dark sky, you can probably pick them up with your unaided eyes, but definitely they'll show up nicely in your binoculars. So you got those to check out. You can also head on over to 42 and 43, which is up here. So if you want to head up and look at Menkellinan and check out, you'll definitely notice the reddish or orangish colored pi star above that. And then if you swing over to the east of them, kind of make a right angle, you can look for a closer pair of stars, 42 and 43 Aurigae. They're about a magnitude 6. They're kind of orange and white when you magnify those. And then from here, we can remember to go down and check out your binoculars, the hitching post combo of Nu, Tau, and Upsilon Aurigae. These are magnitude 4 and 4.5. And then, of course, the tent that I talked about already. And then below that, if you want to go down to the lower part of the ring here, this will be a nice view as well. You've got this neat little clump in here. This is where a lot of the fun DSOs are sort of tucked away. I'll come to those in a second. But, down here you've got this nice pair of 19 and 18 Aurigae, 17 and IQ Aurigae, sort of pair, and then the singlet of 16 Aurigae, which is a little bit brighter. And keep going, you can sort of pick up 14. So you can make this neat little asterism. I haven't learned if anybody has given this, made an asterism out of this group of stars. But I bet you could if you used your imagination a little bit. That might be fun to do. Now, if you want to pull your telescope out and check out some double stars, one of the top ones that are recommended is Omega. So Omega is sitting here between Cycloteni and Hasela, or the Kids and Hasela, and close to that 1 and 2 pair. Omega is also known as Struve 616. It's magnitude 5 and 8.2, and under magnification, you should expect to see perhaps white and bluish as the 2 stars. They're separated by 4.7 arc seconds. Next one I've got up on the list here is 26 Aurigae. That's north of Elnath. So pick this one up, northeast of Elnath. So 26 Aurigae. This one is a magnitude 5.5 and 8.4, very tight, very close spacing. So this will be yellow and blue in color. And there's actually, there are a couple of different ways of counting the double in this case. You've got a very tight pair here. You've also got a more widely separated partner to the south. So you can sort of enjoy that multi-star view of it. That's Struve 753. Then we've got, and by the way, when I was, panning around looking at the various sites to see in Auriga, I noticed that this star named Andrew star popped up, and I was curious about what that meant, what that was all about. And apparently a gentleman by the name of Andrews published a study where he postulated that this was a flare star that had an outburst. So I haven't seen too much more information about that, but that might be something for folks to check into. All right, now we've got from there, we can jump over to 14 Aurigae. So that's a triple inside here. So that's part of that kind of asterism I was proposing a couple of minutes ago. And if you zoom in on this one, it's Struve 653, and it splits as follows. This is actually a triple system, and its magnitudes 5.1 and 11, which are yellowish and bluish, and separated by about 11 arc seconds. Some people refer to this grouping as the flying minnow asterism, though I haven't looked at it myself to see if it does look like that. That's the 14. Next up, I've got Auto Struve 147. That's near Dolonis 2. So we want to head back over into this empty area. Here's Dolonis 2. And zoom in a little bit here. And we're going to go to south-southwest. I think it might be, let's see. I'll do a search here. It's HIP 31340. There we go. This is a cute little double, tight double. It's magnitudes 6.6 and 10 and 10.6. So there's actually 3 in the view, blue and yellow separated by 43 arc seconds. And don't forget to check out the carbon star, BLL 17, shining nearby, also known as UU Auriga. So that'll be a neat, rich color. Last up here in the doubles, I've got a couple more here. I've got Struve 644, which is south-southwest of Alhiba 1. So head on into here. So we've got, I think it's this one here, Struve 644. This is a tight double, magnitude 7 and 6.8. Nice blue and orange, very, very tight, 1.7 arc second separation. That'll be a challenge requiring a good size scope and good seeing conditions, stable air. And the last of the telescopic doubles I've got noted here is Struve 845 or 41 Auriga, and that one is northeast of McAllen. So let's pick up this one. 44 Auriga should be, oops, there we go. There we go, this one here. And this is sort of a matched pair of magnitude 6.2 and 6.9 white and bluish stars, separated by 7.7 arc seconds. And again, while you're in the neighborhood, check out how orange looking Dolonis 1 is. That'd be a neat one. So that's a sampling. If you look at a reference like the Observer's Guide, you can pick up a number of other doubles that are in the list, but none of these, I don't think any of these are in Rask's list of double stars, but there's definitely something for everybody in this list. So I'll pause there for a second and see if anybody had any questions or comments.
We did have a comment related to Auriga and the comet. Where would it be? Is there any way you can throw on the comet's position so people can see where it is relative to the constellation right now?
Yeah, so again, this is tonight's sky. And lucky for us, the comet is going to be parked right beside Aldebaran. All right, so there's the comet. And I'm going to turn off the north here for a second so you get a sense of it. So if you turn and face, this is now the horizontal coordinates. So if you face south-southwest in the evening, mid-evening, find Aldebaran, and you're going to be looking for the comet about a thumb's width to the left and a little bit up. And by the way, I don't know if anybody truly appreciates the sort of speed of things, but if I center on a different star through the evening, let me just put this back to the north up so you can get a sense. That's how fast the comet moves each hour through the evening. So if you go down after dinner, I think we get into the end of astronomical twilight around 7:30. So at that point, the comet would be here with respect to Aldebaran, but each hour that goes by, it's sliding in that direction. So good question, yeah. Anybody else?
Any other questions? Just checking YouTube here. No more questions so far.
All right, good. So let's talk a little bit about
we got one in, sorry. Just curious, each time we discuss a star, it has a label that I would perceive as sigma. I hear you pronounce it as Struve?
Oh, Struve, yeah. So the a couple of astronomers. They were related to one another. There was Struve, the father, and I think Otto Struve, the son, were specialized in double stars. And so they created a catalog of double stars. And that's why you get that code. So when you're using Stellarium and you look at, say, Omega here, you can see the Greek capital sigma letter followed by the numeral in their catalog. So those are the Struve names. So most of the time, so all of the stars will have designations from various catalogs or data sets. So when you're looking at a star in Stellarium, if it doesn't have a proper name, it could have a Greek letter. It could have, instead of a Greek letter, it could have a Flamsteed number. And by the way, the Flamsteed numbers increase from 1 on the west to the highest count in the east. So that's why this was 1 Auriga and 2 Auriga. And then Omega is 4 because we're going west to east. And then each star will also have its designation in another star catalog. So we have the Henry Draper catalog, the HD code. We have the HR, not sure, I can't remember the name. That might be Henry Russell. And then HIP, it is the Hipparchus catalog. So you'll see stars, listed with different designations. And hopefully you're using an app like Stellarium or Sky Safari or some others that list the various identities of the star, then you'll be fine. Cool. Anybody else?
Not at the moment, but I will be sure to stop you when it makes sense if everybody else has questions.
So I'm just going to brighten up the Milky Way and turn off the dark sky for a second here so we can see. Let's do this. So you can see, you remember from our tour of the Winter Milky Way a couple of weeks ago, that the outer rim of our galaxy sits up here in this patch of the sky, sort of the Auriga, Perseus, Cassiopeia zone is looking at the outer edge of the disk of the Milky Way opposite the center of the galaxy. And you do get less Milky Way action, less bright, and some dark dust that sort of interrupts the plane of it as well. But you can see that as far as the constellation of Auriga goes, the Milky Way basically hugs the kind of southwestern sector of the constellation running up through here. And that's actually loaded up the lower southwestern part of the constellation with all kinds of neat objects. And I just thought I'd highlight a few of the cool ones that you can check out. Now, the open clusters are relatively easy to see from the city. So if you've got a smaller telescope or if you live in the city, and you can pick up a lot of the open clusters. Obviously, to start off with, we've got 3 big ones we can talk about, and those are the 3 Messier open clusters, Messier 36, Messier 37, and Messier 38. That Night Sky Observer's Guidebook that I mentioned, if anybody's interested, it lists actually 41 deep sky objects in the constellation. William Herschel, though, he only discovered 13. So I'm just going to highlight some of the best ones to chase after. So if you search between sort of theta, kind of through here, kind of between theta and Hasela, sort of pick these two stars on the ring and focus your finder scope or your eyepiece at lower power midway between these 2 stars. That's where you're going to find Messier 38, the open cluster Messier 38, just sitting right here as you can see it. So this is going to be large in size. It's going to show a relatively loose scattering of stars, and its actual nickname is the starfish cluster. You can see here the letter pi cluster. I guess at times you can pick the Greek letter pi out of it. That's M38. That's a great one. And that's definitely visible in binoculars and any size of a telescope. So that's worth checking out. And you've also got nearby, when you're in the neighborhood, you've got another nice open cluster called NGC 1907. It's a lot less, less bright and a little more spread out, not compact, but it is a nice little rich patch of the sky. So check that out, NGC 1907. They'll be kind of sharing the same eyepiece field of view together. Then if you go from there, you can pick up NGC 1893. Let's see if I can find that one. NGC 1893. Where did that go? 38. Let's find it here. There we go. That's this patch down here. So now you're heading down into the zone between Elnath and Hassela. Kind of make a triangle on the inside of the ring with those. And you pick up this nice open cluster. I'm just going to turn off the nebula picture so you can sort of see the stars themselves. You know, a lot of telescopes won't pick up the nebulosity, but they will pick up the cluster. And this is actually nicknamed the letter Y cluster, because if you squint your eyes, you can see the brighter stars of the group make this sort of almost flux capacitor shape or letter Y shape. 1893, that's a good one. All right, what's next? Oh, and by the way, the reflection nebulosity, the blue nebulosity you're seeing around that, this is the object that's nicknamed the tadpole. So if you've ever heard of anybody talk about imaging the tadpoles, the combination of the blue scattered light and then the dark dust producing this tadpoles DSO. All right, now heading back up. So we found M38 by splitting the difference between these two stars. Now you can pick up the other two Messiers by looking at the line between Mahassim and Elnath. And if you go midway along that line and hop a little bit inwards, you're going to pick up Messier 36. So here's Messier 36. Messier 36 is nicely concentrated, and you will see some stars arranged in curves or arcs, and that's given it the nickname the pinwheel cluster. So you want to check that out. And then sitting opposite the boundary from M36 is M37. So again, midway between the two, but now hop outside instead of inside, and that's where you could pick up Messier 37. And Messier 37, you can see here, is very rich and much denser. So it's a very dense collection of stars. This one's nickname is this January salt and pepper cluster, or the Auriga salt and pepper cluster, mainly, or perhaps because it's also got a mix of different colored stars composing it as well.
So can you see both those clusters in binocular field of view at the same time?
Yes. Yes, so you can do them two each at a time.
Are they decently visible in binoculars? I notice they're quite small star clusters.
The Messiers are definitely strong in binoculars.
Awesome. There, two for one. You get one
more. 2 for 1. Well, you can do these two, and then you can slide and do these two.
So
sweet. You can't quite fit all. Maybe you know, maybe you might if you're lucky. If you got wide field, you might, but 2 and 2.
That's
two at
pretty
a time.
good. Especially being like almost smack in the middle of two of the bright stars of Auriga, like brighter stars.
Yeah. Those are easy ways to find it. So as I said, split this difference, M38, and then if you put M38 to the upper left, and again, this is now, remember, I've got this aimed with north up. So there will be times of the year and times of the night when this will be rotated. So what you want to do is go Mahassim to Hassela, find M38, and then move in the opposite kind of direction from Capella to pick up 36 and 37. So the anti-Capella side, rule of thumb. All right, now let's go for a couple of smaller, fainter clusters. So this is one of the ones I looked at last night. So up here near the kids, and again, I don't know that you wouldn't see this one in binoculars, so you want to pull out your telescope. But if you pick up, you know, the kid triangle here and head west from there, you can see this. And by the way, if you can see Almaz, you can slew in the direction of this medium bright star 59 per and pick up NGC 1664. And this one's nickname is the kite cluster. I'm just going to zoom in here. I don't know if you can see. So what we've got here is let's just do this. But I know I was looking at this one last night with my telescope. So it looks like a little heart in honor of Valentine's Day. composed of a dotted star. So it's like dot, 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 outlining the heart of little faint stars. Empty in the middle, relatively empty in the middle. And then there's actually, they call it the kite cluster, even though it looks like a heart, because it's got a little string of stars that drift down south from there, passing this magnitude 7.5 star. So I thought it was really cute. I'll just show you the Sloan Digital Sky Survey image if I can pull it up. Get a sense of it. So let's see. Let's go on.
While you're doing that, we had a question about the aperture of your telescope. You'd probably want to look at this with. Is it visible in a small one or a medium?
So it really depends on your sky conditions. So I'm actually using a big 12-inch telescope, but I'm sitting on my driveway with all my other neighbors with their lights on. So I don't have very good conditions. In fact, the neighbor across the street had a gigantic bright light shining right towards me. So I could see it fine in my big scope. But if you've got a, if you've got an 80 millimeter telescope or a 70 millimeter telescope, you'll have no problem if you get out away from the light. So sit in a dark spot or on a dark night. So yeah, good question. Let me put this back to normal as it was. So I highly recommend that one. It's very, it's cute. It's very neat little cluster. And then we've got another one here, NGC 2281. So that's going to be in the interior here. Let's pick this one up. 2281 is out in the eastern section near the Delaunay star. So you can use your binoculars to identify the grouping of the Delaunay star or the Psi stars, and then you can look below this main grouping for NGC 2281. This is nicknamed the Broken Heart Cluster. And I'm not sure where the Broken Heart comes in, but anyway, you check, you look, you let me know what you think when you see it, and can explain the Broken Heart. Looks like there's a neat little triangle in the center that would be fun to see as well. So that's a cool one. This one would be sufficiently bright to see in binoculars as a little, collection of medium bright stars. So you should be able to pick those up as well. And then finally, we've got the last one I've got in the open clusters is NGC 1857. So that's in the triangle, the Alhiba tent. If you go back to the Alhiba tent, you can pick up in the middle of that, NGC 1857. And this one is cute. So what I'm going to do is I'm going to actually do the digital sky survey image again. Turn off the stars. So when I look at this, it sort of reminds me of the ET cluster or the owl cluster in Cassiopeia, kind of the, you've got some dominant brighter stars, then you've got a sprinkling of other stars that make kind of a form. It doesn't have a nickname, but, feel free. Think up one. That looks like one that'd be pretty easy to see. All right, let's see what else. So that's it for open clusters. That's not all of them by any stretch. You can see all the little yellow dotted circles here all represent the open clusters in the constellation, and you can keep on exploring if you feel up to it. Any questions?
Don't see any now. Oh,
Okay.
while we were looking at the kite cluster, I noticed that nearby there was something labeled Biddleman's peculiar star.
Yeah, I noticed that too. I don't know what that one is either, but somebody can look that up. Let us know maybe.
Wondering what's so peculiar.
It makes you think maybe you pick a star, do some research on it, and get it named after you. Maybe that's simple as it goes. Yeah, I'll have to look that up sometime and see what that is. That's actually part of Perseus. Okay, let's wrap up with a few nebulas in this constellation. So the most famous one is the Flaming Star Nebula. That's this big green outline you see here, kind of almost a boomerang shape. and it's also known as IC, or Index Catalog number 405. Now, this is not very bright visually, so you do need to be where it's very dark, or you do need to have a very large scope, and you could probably get some help from a UHC filter or an oxygen 3 filter. I have seen it, and I did find it a challenge to see it very clearly, but you know, if you've got good sky conditions, you can certainly pick it up. It's very big. It's actually almost twice the diameter of a full moon. And so that means you don't want to magnify it, overly magnify it too much. Give yourself plenty of real estate so you can sort of move around and see the edges of it. You can actually kind of tell when you leave the bright section and enter the dark section around it. So that's the Flaming Star Nebula. And near that, we've got the Fly. So the Fly is actually the next brightest one, I think, in order. So here, remember, we're here with M38 and M36. If you make a little triangle to the southwest, then you look for this little knot of nebulosity. It's actually this one, NGC 1931. So there's actually two of them in here, but 1931 is the sort of more compact, more brighter section. And this is called the Fly Nebula. It's a combination of emission and a bit of reflection nebulosity in the group. And this is actually one of the finest NGCs. So it would come up down the road in one of our future finest NGC lists. Now, between that, I think this is the one you use. Samantha's got some of these objects behind her in her background, but this near the Fly, we have the Spider. So we have the Spider and the Fly. The Spider is NGC 417. And you can see here that there's a bright central part with a nice bright star, Phi Auriga, close by. That's, you know, magnitude 5, so quite a standout star. But the nebulosity itself is sitting a little bit to the east, southeast of Phi. And, you know, if you've got your sky conditions aren't very dark, your telescope's not very big, what you can look for is, you know, not the nebulosity, but the cluster, the stars being formed in the star forming region. So this pair of stars I noticed here in the center, they both are doubles. So if you can split them up, maybe you can see that little pattern when you zoom in to the center stars in IC 417. So that's fun. Let's bring this back. That's the Spider and the Fly. And the last one that I want to bring, I already mentioned the tadpole. So we've covered basically these four big nebulas inside the ring. The last one I want to bring out is one that I only learned of a few years ago, and that is in the sky to the east of Elnath, which is the horn star of Taurus. There's this terrific faint, I guess it's it could be a supernova remnant. It's called Simius 147. That's SIMEIS 147. It's 3.3 degrees by 3 degrees. And let me just show you, I'll show you the NASA APOD target for NASA APOD picture. Let's see if I open this up. This works. So here you go. So that's this object on the left. So this is kind of rotated around. So there's your Flaming Star, the boomerang. Here's your Spider and the Fly section in here. Here's your M36, M38, and then this is Elnath. So Capella would be off to the right on this picture. And then we're looking kind of southeast, and there's the Simius 147. So if you're an imager and you need a nice big target to go after, that would be cool. Check that one out. Right. So that's my tour of Auriga for you. Hopefully you found some things to check out and get inspired about. And anybody has any questions, I'm happy to take those, but that's good for now.
Give a little bit of a moment for people if they have any questions to type them out. I never think about the Auriga constellation. Now I'm gonna, every time we do one of these deep dives, I start recognizing them every time I look up at the sky. So
yeah,
this will be on my list.
Yeah, so it's fun, you know, even if you just got binoculars, it's fun to be able to pick up these little groupings and things. I'm going to be sure to do that myself when I'm.
We don't have any questions. All right. Oh, please comment on the Venus So a couple people, somebody asked, are these talks recorded? Yes, all of these talks are live streamed on YouTube. Hello, YouTube friends. And then they're put into the Insider's Guide to the Galaxy playlist, as well as the link is on ras.ca / insiders guide. And the link for the episode is included there as well. Somebody asked you to comment on the Venus-Neptune conjunction.
Oh, sure. Okay. So I don't, this is tricky. This is a tricky one because Venus is about 57,000 times brighter than Neptune is. But, you know, Sky and Telescope in their Sky This Week article, they suggested that you could use Venus to spot Neptune in your binoculars. I'm a little skeptical, but I'll just sort of show you how it's working. It's tonight and tomorrow night. So the sky is being carried downward, westward towards the sun every day, while Venus is still swinging east away from the sun. So that means that Venus is going to be consistently passing by these objects. So tonight we've got, and I'll just bring up telescope view, field of view. And again, always be careful with a telescope, you know, towards the sunset, make sure the sun is gone before you use it. But there's a 1.5 degree telescope field of view. So that would be kind of a, you know, a 6-inch Dobsonian with a 25 millimeter Plosso lens in it, that sort of a thing. So if you can try to spot Neptune to the upper left of Venus tonight. And when you're doing this, what I recommend is just drop Venus out of the field of view. So see if you can hide its brightness and pick up blue Neptune. So that's tonight. And then tomorrow night, I'll just do this so you can sort of see the difference. Tomorrow night, they'll switch places. So now Venus will hop past Neptune and it's kind of the same distance, but now it works in reverse. So just stick Venus above. So that one's tricky. Good luck. Let us know if you see it. The one that I'm waiting for is the one on March 1st. That's when Venus will kiss Jupiter. That'll be a neat one. So they'll share the eyepiece on the 1st. Cool. Anybody else?
Somebody said, discovered after a bit of research that Biddleman was a big fan of square dancing. I'd say that's pretty peculiar.
Okay.
So I think that is everything. And I guess it's time for our Finest NGC's corner.
Yeah, let's do it. Okay, what I'm going to do here is I'm going to turn off these markings. I'll just turn off that marking here. And so as always, what we're trying to do here is march through the winter NGC objects. I'm just going to bring up my bookmarks. And I selected, I've got 5 to show you this afternoon. Put this over here like this. And so, you know, we're trying to see these objects when they're culminating or close to their highest point in the sky, because that's when we're viewing them through the least amount of Earth's atmosphere. So this week we have a moonless evenings, and we've got the sky getting dark. I think I said it was at astronomical twilight is finished at 7:30 p.m. So let's put the sky to 7:30 p.m. Looking south, we've got, of course, Orion, Taurus, Auriga. And then if we flip this around and look north, then we've got Polaris, Ursa Minor, Camelopardalis, and then so on. So we've got the green Z is the zenith overhead. So first up, we've got the Flame Nebula. The Flame Nebula is in Orion. So I'll bring this into view. Completely super easy to find it because it's parked right beside the eastern star of Orion's belt, Alnitak. It's a relatively bright combination of emission nebulosity and dark foreground dust that is breaking up the larger patch of nebulosity and producing these sort of enchanting shapes. So some people think it's a flame, some people think it's a maple leaf. I read somewhere it was nicknamed the tank tracks. I'm not sure what that's from. There's the Ellipse Nebula, Burning Bush, Ghost of Alnitak, that sort of thing. So it was discovered by William Herschel back on January 1st, 1786. It was his class 5 object number 28, so B-28. I've seen people claim to be able to see its glow in big binoculars from a dark sky. Don't know how reliable that is. But really, I recommend, say, if you've got a 4-inch or bigger telescope and a dark sight, then you should be able to pick it up. Obviously, super easy to find it because you just need to point your telescope 1/4 of a degree to the east of Alnitak. You probably want to actually hide the bright star outside the field of view just to help you see it. I'm just going to show you the simulated view. So this is the 6-inch Dobsonian telescope through a 26mm eyepiece, and that gives you kind of the field of view. It's actually about 30 by 30 arc minutes, but the brightest areas are a bit less than that. But you can maybe with a bigger telescope see a bigger size to it. So what you're going to look for is the orientation and the shape of the dark dust. As I said, you can magnify it at, say, 35x, or maybe even, let's just go here to double that. Let's try the next one, 14mm. So, 65x would probably be a good magnification. I didn't find that a filter, an ultra high contrast filter, helped me very much, but you could certainly try it. You want to look for the shape, the dark dust. You want to note its any sort of picture you image it, or picture that you imagine, or maybe you could sketch it. And don't forget that Alnitak itself is a double star, so you can split that and look at that when you're there. And that the Horsehead Nebula, which isn't really a visual target. It's one of the RASC's challenging. I think it's one of the challenge targets, but it's nearby as well. So that's the Horsehead. Okay. Next up, we've got the Kissing Crescents Nebula. This is a planetary nebula, and it's in the northern part of Orion between Betelgeuse and the head, Meissa. And one of the ways that you can find this object, and I did this last night, is put your telescope on Meissa. So we'll just do this. And let me just change the magnification back down to the 26mm Plossl. So this star pattern is very, very recognizable. You've got Meissa, Hecla, and a line of 3 stars connecting them. Then from here, you're going to hop in this image to the right, but it's actually to the east, to Phi 2 Orionis, and then keep going a little bit further. You're going to pick up this little pair. And eventually, let's see if I can put on the symbol here. Once you've got this little pair, then you can pick up NGC 2022, the Kissing Crescents Nebula nearby. Now, this is a really tiny object, so I didn't see it last night. I looked, and I didn't have my O3 filter to brighten the planetary up, but I didn't have a lot of eyepieces available to zoom in too much. But I would say you need a medium to large aperture telescope to really enjoy it. You really do need to magnify it a good amount. Let's see, I suggested to crank up the power beyond 100x if you have it. Just sort of simulate that here. We can go to 14, and I'm just going to actually put a Barlow on this. So you can start to see the little shape, little disc of it as well. You can, if you have an O3 filter, you can brighten it with that. You want to use averted vision. You might be able to see the blinking effect where it gets brighter and dimmer as you look at it and look away from it. And I think if I zoom in a little bit more, I'm just going to come out of this and zoom in manually. So it's a really cute little object, but you really have to crank up the power to see the details. So you might be able to pick up the central star, and you might even be able to pick up some of the non-uniformity to the structure. So do note that, and then, enjoy the rich star field around it at the same time. Next one up is now changing horses. We're going to go into the northern sky. So let me just flip this off. So that's 2 objects in Orion. We're going to flip around and go into camelopardalis. And we're looking at here is the Oyster Nebula or Camel's Eye Nebula, NGC 1501. So let's just go here. And this one is actually right near Kemble's Cascade and the Jolly Roger clusters. So if you see these two corner stars of camelopardalis, if you can see this line of stars here, that's the Kemble's Cascade chain of stars. And then you've got this little clump here, that's the Jolly Roger cluster. And once you've got this one, then you can pick up the Oyster Nebula in the same neighborhood. So let me just zoom in on the Oyster Nebula here for you so you can see it. As planetaries go, this one's a little bit strange because it doesn't have that shell kind of characteristics that we're used to. This may be because it's a relatively younger planetary that hasn't had a chance to kind of expand out and differentiate as much yet. It should be visible in any size of a telescope. It's about magnitude, it's brighter than 11.5. It's more like 10.5 magnitude. If you want to see its form though, you really want a larger telescope. So what I recommend doing to find it is to, I'll just swing back here. If you take Cassiopeia and you draw a line from Cassiopeia to, let's see, Segin, the last star, so the first to last, and double that, that'll land you basically on the Jolly Roger. Once you're on the Jolly Roger, it's really only a thumb's width from there. So they'll actually share the field of view if you've got a low power, say a 1.5 degree field of view. So let me just put this in the eyepiece for everybody. There we go. So that's seeing it at about 125x. So you really need to crank up the power to see it well. You can use an oxygen 3 filter or a UHC filter to brighten it. You want to notice its size and shape, its orientation, and any structure you might notice, any nearby field stars. There are some field stars in the neighborhood. And then when you're there, don't forget to enjoy Kemble's Cascade and the Jolly Roger. So this thing's about 5,000 light years away. Okay, we got a couple more. Still in camelopardalis, we've got an object that's called NGC 2403. It's actually one of the Caldwell objects. So that's kind of in an empty, featureless patch of camelopardalis. This is actually a galaxy. And if you zoom in a little bit here, you can see it's relatively bright, really, really nice, pretty galaxy. It's visible from a dark site in binoculars. It's big enough to see in binoculars. It's about 24 by 13 arc minutes, so about the size of a half moon in basic dimension. Discovered by William Herschel back on November 1st, 1788. It was his object 5, class 5, number 44. It resembles the fireworks galaxy, NGC 6946 in Cygnus. Now, the way I found it was I used the star HR 2209. So where's that one? Let's just find this one. HR 2209. Right. So this star HR 2209 is a relatively bright star. And it's, if you look between that star and the nose of the Big Bear, so this is Ursa Major, this is the tip of the nose of the Big Bear, then the galaxy is sitting halfway between these two. So you can just aim your finder midway or your binoculars midway and pick up the galaxy that way. Or you could take the line from Theta Ursa Majoris. So if I take the front kind of arm joint of the bear up to the nose and go about 1.6 times that distance, then that also will pick it up. So you've got a couple of options there. Let me just put this in the simulation for us. So there's the view at 128 power. That's probably more than you want. Let's just put this back to, let's take off the Barlow here. No Barlow. There we go. So it's about 65x. It's a good amount to view it as. Do you want to note the characteristics of the core, the shape, the orientation of the disk, the texture, Look for some embedded field stars. So there's actually some foreground stars in the disk of the galaxy. And then there are some nice surrounding stars as well that can really confirm the star field for you. All right, and last up, we've got NGC 2655. This one is also in Camelopardalis. This is sitting down near Polaris. So if we zoom in on this, get this really pretty interesting, pretty looking galaxy. So this is what's called a bright lenticular galaxy. It's a combination of kind of a lozenged plus some arm structure to it, some spiral structure, discovered by William Herschel back on September 26th of 1802, and he classed it as object class 1, number 288. Now the core is very bright, so you can really see that in any size of a good quality telescope. But if you want to see the nice structure around it, you're going to need a bigger aperture telescope. So it's not near any good helper stars, but what I did is I used the star HR 3751. So let me show you where that is. And again, that was a star I could see. That's kind of this orange star. And from there, I actually star hopped from there. So let me just highlight these so you can see where these are. I'll pick it up. There we go. So from there, I kind of made my way following the star patterns from there. You could also, another way of doing it is to take the Big Dipper's bowl. So I used, let's see, it's Megrez. And I split the difference, let's see, from Megrez to Lambda Draconis. So where is Lambda Draconis? So here. So if you take this star, in the corner of the Dipper's bowl, go to the tip of the dragon's tail and double that distance, and that'll bring you to the galaxy as well. So you want to use this one. Do your searching at low magnification. Let me show you the view here. And then once you've got it, you want to start cranking up the magnification to see a little bit more detail. So look for the halo around the bright center. Remark what you observe about the core itself, and you want to look at any orientation and shape that you might make out, and look for the nice little field stars around it. There are a couple of really bright little cute ones around it as well. And there is a galaxy in the neighborhood, NGC. There are actually a few galaxies in the neighborhood around it. You've got NGC 2715 nearby as well, if you're in the neighborhood. So this one's about 80 million light years away. So that's it. That's 5 for this time around, and we'll stop there.
Perfect. We have just, if anybody has any questions about the finest NGCs, throw it in the chat. We have an unrelated question, and maybe people in the chat can also comment on this. Someone found the app called Dark Sky Meter and was wondering if it's worthwhile to test their skies, if it's decently accurate.
I'm not familiar with that. Is that measuring the sky, or is it reporting the light pollution data?
I think it's recording. I looked it up with, I think it might have to do with the light pollution side of things, like what your, like an SQL meter. So yeah, if anybody is familiar with that.
I haven't used it myself, because one of the main reasons is that I'm an Android user, and the cameras on Android devices are less kind of regimented as the Apple devices. So the Apple devices are able to be used more as a scientific instrument because they're more calibrated than the variety of cameras you get on various Apple Android phones. So I know that when I've spoken to developers of night sky camera apps and things like that, they always say, well, it's easy for the iPhone, but it's hard for an Android phone. So I've heard of apps that you can use an Apple phone, an iPhone, to almost for photometry, where you can measure an accurate light reading, but they're just too variable in the Android phone. So they can't make an app for every single device, so they don't tend to do it as much.
I will say, based on a quick search, Rask centers, there's a few, particularly on the West Coast, I've picked up that have advertised this app. From what I've heard in general, is apps are never as accurate as a like real SQL meter if you're looking for the sky quality. But go ahead, try it. It seems like other people are using it, and as well. I see that, Chris, you've brought up the light pollution map here.
Yeah, this is one of my go-tos. It's the lightpollutionmap.info. I mean, it's great if you're planning to go somewhere and look, seek out darker skies. And one of the great things about this website is that you can actually select from a variety of different layers. So this World Atlas 2015 has got and if you mouse over, we just pick this. If you click on area, then it actually reports to you, oh, there we go. It reports to you the SQM reading and the Bortle class reading. So you can actually query it to figure out, where you're going to go. Now this is from 2015, yes. So there's another alternate layer in here. You can go to the various VIIRS maps. And these are kind of views from space of the light pollution. So you can kind of use this to look, what's happened in the last few years to a particular area you might be interested in going to. And I'm not sure if you can still click on a map. Yep. So you can get its radiance value. It's actually giving it to you over time, so you can actually get a readout of whether things are improving or not over time. So that's a really nice tool.
If you're interested more in your local like sky quality, I definitely recommend connecting with members of your local center, because I know depending on the center, some centers or have people in there that focus a lot on light pollution abatement. So they would be a very good resource to know what's up in your area. So
I'll hand it over to you now, Samantha.
Okay, well, thanks for you who stuck to the end. Little announcement. This will be my last Insider's Guide episode. So thank you all for being so welcoming. It's been such a fun year of doing this. I am departing from my role at the Royal Astronomical Society at the national office at the end of the month. I am moving into to another outreach education role in my local area. But thank you everyone for all the welcoming that you've done, and all the insiders guides, everything you've come up out to. Thank you, Chris, for everything you've done. And I will be, if anybody's in the local Toronto area, I will be at the Outdoor Adventure Trade Show, which will be in Mississauga. That will be my last hurrah. My last days will be out there talking up Rask. And yeah, with that being said, I don't know if you want to talk about where Insider's Guide is going to be heading with that.
Well, let me just say first, what a heartfelt thanks I have for you and for Jenna before you for allowing me to come on and prattle on for an hour and a half every couple of weeks. It's been really great. As you mentioned, we've done 65 shows, and you've been great as a co-host, and I'm going to miss you like crazy, as I miss Jenna as well. And what we'll do is we'll decide whether we can proceed by finding another co-host. So if anybody has any ideas about how to go forward from here, we'd be happy to hear them. Please get in touch and let us know. But it's been a great run. Thank you so much.
Yes, thank you. And if anybody has any ideas, you can email outreach@rasc.ca. And thank you all for all your kind words. All the Insider's Guides folks get to be the first to hear it, so I appreciate everyone. And I will be still sticking around as an RASC member, so catch me when
Me too. I'm not going anywhere.
Chris is not going anywhere. Don't worry. You just won't see my face as much. Yeah. It's really exciting to now have the time to go stargazing and join star parties and all of that. So
yes, I promised Samantha I would get together with her and do some stargazing sometime.
Got to. I still have to go to the DDO before when it's dark outside.
Yeah.
Only ever been there when it's bright.
Perfect.
Okay.
All right. Well, thank you, everybody. Thank you, Samantha.
Thank you so much. Have a great rest of your week. And
Keep looking up.
keep looking up. Yeah. Bye all.